Very good morning, my dear students. Let me see the tutorial on conduction, unit 1 with heat generation. We all know what is meant by heat generation that I explained in the class. During the class, I have explained with heat generation, without heat generation. We solved the problem not considering heat generations concept. Now in the tutorial, the problem which I am going to elaborate to you is, which I have not solved in the problem, that is due to heat generation, what will be the effectiveness? What will be the effectiveness? Let me get into the problem. So a 10 mm cable is to be laid in atmosphere of 20 degrees centigrade with outside heat transfer coefficient of 8.5 watts per meter squared Kelvin. That is H, heat transfer coefficient. The surface temperature of cable is likely to be 65 degrees centigrade due to heat generation within. So as I said already, due to electron flow in the cable, there will be generation of heat within that. Will be rubber insulation of K, thermal conductivity 0.155 watt per meter Kelvin. Very minimal value. Be effective. If yes, how much? So they are asking question, if I insulate a rubber insulation for arresting the heat generation to avoid the accident or heat dissipation nearby, so what will be the thickness needed? What will be the heat transfer? Is it will be effective? Likewise, they are asking the question. We know already. So when do we say it is effective? Based on the problem given here, we know that the value which is greater than 5 watts per watts will be said as effective. Based on it can be referred in the heat transfer data book also. The theoretical problem also we have seen. So the given data is radius, which is the given diameter, that is 10 by 2 5 millimeter is the radius. Ambient temperature is 20 degrees centigrade. Temperature is given as 65 degrees centigrade and heat transfer is given as 8.5 watts per meter squared Kelvin. So for a cable, it is considered as a cylinder. We know that K equal to R into H. Similarly, RC which is equal to K by H. RC is critical radius. So 0.155 divided by 8.5. So already we have seen the unit clarification in the previous problem, watts per meter Kelvin divided by watts per meter squared Kelvin. We will get 0.18295 meter and in the full rounded value 18.235 millimeter. Hence, the rubber insulation of thickness T which is equal to RC minus R1 which is equal to 18.235 minus 5, R1 which is given as 5. So 13.235 mm will be effective because already we have seen 5 watts per meter square and the same way the similar value given as 5 millimeter. Here it is 13.235 millimeter will be effective in heat dissipation. So now let me see maximum heat dissipation per meter length formula we have seen in the class also, derivation part also, and which is available in the HMT data book also. Q maximum divided by length which is equal to 2 pi into T1 minus T infinitive divided by ln of RC by R1 divided by K plus 1 by H into RC, which is nothing but which is equal to 2 pi into T1 equals 65, T infinity is 20 divided by ln of RC by R1. RC is nothing but critical radius which is 18.235 we have seen, we have found the value. Similarly, radius 1 equal to 5 divided by thermal conductivity plus 1 by H into RC. We substitute in the problem. We know that Q max by L which is equal to 19.1 watts per meter. So here as we discussed, the Q max by L more than 5 will be effective and the length will be for more than 5 millimeter will be effective. The problem they asked, if it is effective, how much is the value? Based on the that is the thickness, insulation thickness, we found that it is effective. It is effective because if it is more than 5 millimeter, it will be effective. And how much will be the value? We have found the Q max by the length is equal to 19.1 meter. So thank you. Let me see the tutorial 3 in the next session. Just remember that with the heat generation, how to solve the problem based on this tutorial.